Hello, so today we will be discussing about the present economy studies. When alternatives for accomplishing a specific task are being compared over 1 year or less, and the influence of time on money can be ignored, engineering economic analysis are referred to as the present economy studies. Okay, so there are rules or criteria that will be shown. I will show you um, in this lesson that we will be using to select the preferred alternative when defect-free output, or what we call yield, is variable or constant among the alternatives being considered. So, so here are two rules or criteria to be used in selecting the preferred alternative. So first, when revenues and other economic benefits are present and vary among alternatives, choose the alternative that maximizes overall profitability based on the number of defect-free units of a product or service produced. Our keyword for the first rule is this one. You choose the alternative na makamaximize ka sa iyong overall profitability. Okay. Second is when revenues and other economic benefits are not present, or are constant among all alternatives, consider only the costs and select the alternative that minimizes total cost per defect-free unit of a product or service output. So you have to choose the alternative or option na maka-minimize ka sa cost, sa total cost per defect-free unit. Okay? Next, so we have a reading assignment. This three, the total cost in material selection, and making versus purchasing or outsourcing studies. And then the trade-offs in energy efficiency studies. So make sure that you downloaded and read this reading assignment that I will be posting separately. So for the total cost in material selection, we have here an example. First is choosing the most economic material for a part, and the second is choosing the most economical machine for production. These two examples are posted in our lecture notes, but for this, for the purpose of this video, I am going to mention and introduce an external source, okay, from an online source na about material selection. So this site, we have I posted the source here at the bottom. This article is entitled Material Selection, and um, this covers the parang steps in choosing the right materials. Pero this kanang article is specific sa new circular design. So murag gi-consider niya ang circular economy. Parang this is in relation to our DFE na kanang topic that I mentioned in our previous na kanang lesson. So material choices play a fundamental role in designing. By choosing only safe and circular materials, you can ensure that products are safer to both humans and the environment, and that the material used to make them can be reused without causing contamination. So actually, daghan in here, daghan kay makita nga mga vast, redundant to, daghan kay makita na options for materials. So, kani man gud siya na site, kani siya na article, mo siya ka ng, yeah, I mentioned DFE, and tapos siya ka ng concern siya sa chemical composition sa isa ka material, but let's try to disregard that one. I listed here the steps. I think these are not just 5 steps, but murag 7, I think. Pero we are only going to choose and elaborate the steps na makarelate ta sa atong main topic na total cost in material selection. So first, create a bill of materials. Okay, so before choosing unsa ang pwede nimo nga ma-evaluate kung unsa ang kana most economic material for a part, you can create a bill of materials, or this is being referred to as a BOM, and this is a good way to get an overview of all the different materials in a product. So pag makita na nimo tanan or na nakay full parts sa list sa imong product, i-identify nimo ang materials that make up each part. And then that's the time na pwede ka butang of option. So for example, take that part, kung unsa na siya na part sa imong product, you can assign a generic material type. So to it is useful to assign a generic material type for each homogeneous material. So pwede nga like metal or plastic, then plastic metal composite. So there are a lot of options pa na pwede nimo kuan, like dyed textile, solvent wood, fabric, fiber, and so even like let's just finish this one. Then the rest of the steps is kanang medyo dili na siya relevant sa atong total cost in material selection because we discussed this in a previous topic. But sige, classify the type cycle is since you kanang if you have identified na a generic material type, then murag diri niya gi-consider ang biological cycle or ang technical cycle sa isa ka material. So designating a material as a suitable for the biological or technical cycle depends upon what happens to a product after the use phase. So after ana, asa na padulong ang material. So material suitable for a technical cycle cannot be consumed or otherwise processed by a biological system. So the examples of technical na mga materials are metals and plastics. This can be dismantled and reused or physically or chemically transformed after their use phase. So, kanipong mga biological cycle na mga material suitable for biological cycle, mura siyang mabalik sa environment. So, again, I'm talking about the katong mga life cycle na sa isa ka material. And example of these are wood, cotton fiber, paper, inana. So, anyway, dig deeper, material screening, napanay ka ng, sa pagalito. Anyway, you can check out the link, feedstock selection and circular design. So, yeah, you can check it out on the link posted. Then, also, this is very important in this part in kanang sa total cost in material selection. Kay gusto man gyud, we all want na kanang makalesta sa cost sa material, total cost. So that's why kinahanglan ni identify nimo ang part sa material nga pwede nimo mabutangan og alternative. Like for example, glass versus acrylic, types of wood. What else? Sa mga walls. Yeah, woods, concrete, plywood, something like that. So, and now for the next na i-consider nato sa total cost in material selection, kay of course ang material selection manggo dili lang siya based solely on the cost sa material. Frequently, a change in materials will affect the design, maka-apekto siya sa design and processing cost. And shipping cost may also be altered. Like, if gusto ka o wood versus concrete, ana bale. So, let's say sa shipping na factor, uh, mas bugat ang concrete i-ship or i-transport. So, mag-matter siya, diba? And we also have choosing the most economical machine for production. So, I also have we have an example for this subtopic, which is posted sa lecture notes. And this is also, I got this from an online nga kanang source, additional resources na to for this topic. So, there are considerations when choosing the best na kanang industrial machines. Okay? So, obviously, we have to consider the cost. Ang cost, ana siya. So, most of the machines that are used in the industries are very expensive to acquire. And this makes most industries to opt for mag-rent na lang sila rather than purchasing the machine. Okay? So, for those industries that can be able to own their machines, it is important to look at the price. Again, kay muad man na siya sa imong production cost. So, you have to do a more thorough look at the budget if kaya ra ba sa company and makompensate ba siya. Of course, the quality, diba? Sometimes, nakaingunta nga, the cheaper the machine is, siguro low quality. But actually, there are also kanang good na mga brands nga ga-offer o same quality on a cheaper price. So we have to look at the quality also. Also the durability. Machines are very expensive, and this requires that while purchasing, we ensure the machine that can serve you for a long time without bringing problems. It could be manggod na kanang like barato ra siya, and then sige, na-acquire na mo siya na barato siya. So, makasave na ka sa total production. But yun po ka sa maintenance cost niya. So, magsige ka og pa-repair and repair. So, diba? So, you have to consider the durability of the product, of the machine. And number 4 is the nature of the job. So, what is the machine for? Okay? Unsay best kung bugat na mga ipang-process niya na kung ang dapat heavy duty pud siya na gani. So, yeah, it says here nga, it will be a waste of time and finances if at the end of the day you come back to the firm with the wrong machines for the job. So, you have to you really have to consider that one too. So, ang price, ang quality, ang durability, and the nature of the job go hand in hand when in purchasing process. So, best quality ng mga machines or what can serve you for a long period of time that are suitable for the working process must be costly to acquire. So, that's why nani siya ng mga consideration. Okay, so, okay, so let's have an example in choosing the most economic material for a part. A good example of this equation is illustrated by a part for which annual demand is 100,000 units. The part is produced in a high-speed turret lathe using a 1,112 screw machine, steel costing $0.30 per pound. A study was conducted to determine whether it might be cheaper to use brass, here we go, screw stock, costing $1.40 per pound. So the brass screw is $1.40. Because the weight of steel required per piece was 0.0353 pounds, okay, and that of brass was 0.0384 pounds, the material cost per piece was 0.0106 for steel and 0.0538 for brass. However, when the manufacturing engineering department was consulted, it was found that although 57.1 defect-free parts per hour were being produced by using steel, the output would be 102.9 defect-free parts per hour if brass were used. Okay, so 57.1 if steel and 102.9 defect-free per hour if brass. Which material should be used for this part? Okay, so we have our problem here. So, unsang material? Brass, steel, or brass? Now, let's try to solve that one. Okay. Sige, let's start with the steel. 1112 steel. Sige. First, ang material, ano niya? Pila ang material. So, ang material would be 0.30 per pound. Tama? Times, times ang pound nimo so that you will get ang amount niya. So, naakay 0.0353. Okay, and this is equal to 0.0106 ang material cost. How about the labor? So, sa labor, nakabutang dari nga, ang machine attendant, na dari, napaisa, machine attendant. Ito siya sa given dapat. Kinabayaran siya o $15 per hour. So, let's include that one. So, 15 over, naamang kay, pila ang defect-free parts na per hour niya, 57.1 sa steel. Tama? Steel. Using steel. So, therefore, you have 0.2627 and variable overhead is, ang variable overhead nimo is, wait, okay, so napa siya isa ka given. Sorry. Given ang variable overhead costs for turret lathe nga $10 per hour. This is given. Sige, so you simply have to so you simply have to divide that one sa katong defect-free parts niya per hour. Ang steel is 57.1. So you will get 0.4484. And the total for steel is per piece kung i-sum up na nimo siya na akay 0.4484. So, for brass, ang material niya is, pila man ang brass? 1.4, no? 1.4 times 0.0384. Muna siya ang iyang kabugaton, 0.0384. So, naa kay 0.0538. Okay? So, how about the labor? Pila ang kinahanglan niya nga kuan na labor? This is just kani siya, uh, for all man ni siya nga kanang kuan rate. So, naa kay 15 over pila to ang defect-free kuan niya? Kani, 102.9. So, na kay 0.1458. Sorry, this is equal. Then, for the variable overhead cost, no, naa kay fixed po siya nga 10. So, you just have to divide that one sa kating kuan niya, 102.9. And you will get 0.0972. So, this is equal, ang imong brass is equal to 0.2968. 0.2968. So, okay. Now, pwede na ta makakompute og saving per piece by use of brass. So, pila ang masave na to? That's 0.4484 minus 0.2968. So, naa kay 0.1516. Now, sorry, this is 16. So, because, let's go back here. Because 100,000 parts are made each year, annual man, okay, revenues are constant across the alternatives. Ang rule 2 nato that we discussed on the first part of this topic would select brass. And its use will produce a savings of 151.6 per thousand. Multiply lang na siya. Or a total of 15,160 for the year. Okay, so nakaana. It is also clear that the costs other than the cost of materials such as ang labor o ang overhead were important in kaning pag-comparison nila. Okay? So that's for example 2-8. So care should be taken in making economic selections between materials to ensure that any differences sa imong shipping costs, yields, or resulting scrap are taken into account. Commonly, ang alternative materials do not come in the same stock size. Nagyud na sila mag-vary, yun na sila. Either sa ilang mga sheet sizes, sa ilang bar length, sa ilang diameter. This may considerably affect the yield obtained from a given weight of material. So similarly, the resulting scrap may differ for various materials. So in addition sa pag-decide kung unsa nga material ang product made of, there are often alternative methods or machines that can be used to produce the product, which in turn can impact processing costs. Either makatipid ka or mas mahalan ka. So, pag mo consider na po ka nga, sige, process na lang, mag-vary na po ang processing times sa machine na imong mapili, diba? As may the product yield. Okay? So, maong ang second nato nga katong na example sa inyong lecture notes, can we check that one? Choosing the most economical machine for the product, for production. So, dira na po siya mo kailangan ninyo i-consider. Okay. So, yeah, that's it for choosing the most economic material for a part. So, let's have example 2-10. See, example 2-10 is under the making versus purchasing or outsourcing studies. If you have read your reading assignment under 2.4.2, section 2.4.2, the making versus purchasing. in the short run, say 1 year or less, a company may consider producing an item in-house even though the item can be purchased. Pwede mo siya actually paliton sa gawas from a supplier at a price lower than ang company's standard production costs. So this could occur if one, direct, ang first na murag factor niya is direct, indirect, and overhead costs are incurred regardless of whether the item is purchased from an outside supplier. And number two, ang incremental cost. Ang possible na kanang kuan niya. Factor na mag-occur siya. But anyway, I am sure that you have read your assignment. So let's proceed to an example. So the question is, to produce or not to produce? So, a manufacturing plant consists of 3 departments. Let's say A, B, and C. Department A occupies 100 square meters in one corner of the plant. So, CA na siya 100, nag-occupy siya 100 square meters. Ang production X is one of the several products being produced in Department A. So, from A na siya. The daily production of product X is 576 pieces. The cost accounting records show the following average daily production cost for product X. So, muna ang record sa daily production costs for product X. Direct labor is 120. Ang breakdown ana is 120 ang direct labor, and ang breakdown ana is kani siya 1 operator, blah blah blah. The direct material is 86.4 and ang overhead cost niya is 82. So pila ang total cost per day? Kaya diba kailangan ka na nakay common unit of measure para ma-evaluate nimo siya. So this is gi-convert ni niya ang 0.82, gihimo niya katong sa floor area niya. Given man siya na kanang variable na appeal sa problem. So, 82. So, total cost per day is $288.4. Muna siya ang total cost. Okay, let's move to is this another department? Wait. Okay, sige. Let's move on. The department foreman has recently learned about an outside company nga gabaligya pud og product X at 0.35 per piece. Accordingly, the foreman figured a cost per day of, so, diba, 0.35 per piece man. I-multiply na niya of 576. This curve of 576. So that is $201.6 in total. Kay ibutang nato butang niya ang 576 kay mao man na ang ma-produce ni product X per day. 576 pieces ang daily production niya, resulting in a daily savings of 288.4. Minus, kung i-subtract nimo pila ang savings niya, it's actually, ang difference niya is 86.8. Therefore, a proposal was submitted to the plant manager for shutting down the production line of product X and buying it from the outside company. Diba? So, makasave man kag 86.8. Ato na lang ni-cut ang production cost, then mag-outsource na lang ta sa another company. Now, however, after examining each component separately, the plant manager decided not to accept the foreman's proposal based on the unit cost of product X. Muna siya ang defense ni plant manager. Number one is the direct labor. Because the foreman was supervising the manufacture of other products in Department A, in addition to product X, the only possible savings in labor would occur if the operator working 4 hours per day, muna siya ang first defense niya, working 4 hours per day on product X were not reassigned after this line is shut down. that is a maximum savings of $90 per day would result. Okay? So, ang materials, ang sa kaniyang kuan, gi-raise is ang materials. Ang maximum savings on direct material will be 86.4. However, this figure could be lower if some of the material for product X is obtained from scrap. So, muna yung solusyon, obtained from scrap of another product. Okay? So, again, based sa atong table, ano siya na table here, diba, 86.4, pero mas mugamay pa ni siya if gamito nila nga material kay scrap of another product. Okay? So, kung i-utilize na nila. Number 3 is the overhead. Because other products are made sa Department A, no reduction in total floor space requirements will probably occur. Meaning, kay ang overhead na gi-consider nato diri sa table sa kanang production cost is kanimang kuan 82, diba? Murag wala ra gyapon effect kung mo-opt ka sa mag-outsource ka kay gamiton man gihapon nimo ang tibuok floor area sa Department A. That's his point. And therefore, no reduction in overhead cost will result from discontinuing product X. It has been estimated that there will be daily savings in the variable overhead costs traceable to product X of about $3 due to a reduction in power costs and in insurance premiums. Okay, so that's it. The solution is if let's say if production sa product X, if the manufacturer of product X is discontinued, di siya magayon, the firm will save at ang savings sa firm naa siya yung $90 sa at most sa direct labor. And 86.4 sa direct materials. And, well, $3 sa variable overhead. These figures are mentioned sa given na the one I mentioned just a while ago. Okay, so, muna siya ang iyang savings, okay? And this will have a total of 179.4 per day. Sorry, this is dollars. Sige. And so that would be 179.4 per day. This kani siya nga estimate of actual cost savings per day is less than the potential. So we have the 179.4 per day nga na-compute, diba? This estimate of actual cost savings per day, kung i-compare nato siya sa cost accounting records nga kaning sa table on your left, that's $288.4. And, diba? 179.4 is less than that accounting cost cost accounting records, and it would not exceed 201.6. Okay, it would not exceed 201.6 na there is sa kanang the foreman figured a cost per day of kaning gi-multiply niya ang 0.35 of 576, ba? So, to be paid to the outside company, kung versus 288.4 versus 179.4 versus 201.6 to be paid sa outside company if ang product X is purchased. So, for this reason, the plant manager used Rule 2, okay, and rejected the proposal of the foreman and continued the manufacture of product X. Right? So, in conclusion, in conclusion, this example shows how an erroneous decision might be made by using the unit cost of product X from the cost accounting records without detailed analysis. Okay, so the fixed cost portion of product X unit cost, which is present even if the manufacturer of product X is discontinued, was not properly accounted for in the original analysis by the foreman. So, okay. So, I hope this example will help you understand more about decision making between making versus purchasing. Okay. Now, example 2-11 is about investing in electrical efficiency. Okay, so two pumps capable of delivering 100 horsepower to an agricultural application are being evaluated in a present economy study. Sige. The selected pump will only be utilized for 1 year and it will have no market value at the end of the year. Pertinent data are summarized as follows. By the way, this example falls under the trade-offs in energy efficiency studies. Okay, so the solution, So this is ang data nasa table. Kana siya, let's say we have the ABC pump, ang pump 1. Pump number 2 is, let's say, XYZ pump. So, purchase price, the maintenance cost, the efficiency. If electric power costs 0.10 per kilowatt hour, and the pump will be operated 4,000 hours per year, which pump should be chosen? So, we have a conversion factor of 1 horsepower equal to 0.746 kilowatts. Sige, the solution would be, say first na to i-consider ang pen. Okay. So, the expense of electric power for ABC pump. Ang iyang electric power expense. So, that would be 100 horsepower over 0.8 times efficiency is 0.8. I mean 80%. Yeah, 0.8. So, you have to, ang conversion factor na to is 0.746 kilowatt per horsepower. Multiply that one by 0.10. Ang 0.10 is the cost nimo, electric power cost. Okay, so 0.10 and times unsa siya kadugay gamiton or mag-andar tang nato. That would be 4,000 in a year, 4,000 hours per year. So, naay mga mag-cancel dira nga variable, and then you will get a result of $37,300. Now, how about the XYZ pump? So, pila ang expense sa iyang electric power? We have 100 HP again. Pila ang efficiency niya? 0.9. And the conversion, i-convert na to siya so that we can cancel out. And then, the cost, unsa siya kadugay, 4,000 hours per year. So, XYZ pump is, cancel out the kanang units, and then, kung imo na siya i-compute, you will have 33,156. 37,300 and $33,156,000. So, thus, the total cost of owning and operating the ABC pump is pila? Pila na. So, naana kay si ABC pump, kani siya, nana ni siya, pila na dayon ni siya? 40,370. Okay, while the total cost of owning and operating the XYZ pump for 1 year is 39,866. So, i-add lang nimo ang purchase price, maintenance cost, and ang kaning electric power cost na ato na compute. So, you will have this kanang figures. 40 o 370. 40,370 and um, $39,866. Sige. So, consequently, the more energy efficient XYZ pump should be selected to minimize the total cost. So, notice ang difference, no? Kung mabantayan ninyo ang difference in energy expense, ang energy expense um, na mag-result from a 90% efficient pump relative to an 80% efficient pump. So this cost reduction more than balances the extra $3,300 in capital investment and $340 in maintenance required for the XYZ pump. Okay, so ilang difference. So this is an example of kung about the investing in electrical efficiency. Okay. So for this lecture, we have ang use sa present economy studies in engineering decision making can provide satisfactory nga mga results and save considerable analysis effort. So when an adequate economic engineering economic analysis can be accomplished by considering the various monetary consequences that occur in a short period of time, usually mga 1 year or less. Ingana. A present economy study should be used pag in cases na kinahanglan nimo i-evaluate or i-consider ang kanang consequences before even kanang mag-decide ka nga okay, let's purchase this product. Let's choose this pump. Mas mahal ni pero mas barato ni. Ang mas barato ba meaning efficient? So something like that. So I hope you learned something, and this is the end for this lecture. Thank you.